All right, students, this is our last lesson for Unit 4 for this semester, and we are going to work on, hold on here, making connections between logarithmic functions and limits. So we're going to bring back some of the limit topics that we explored earlier in the semester and link the two together. So here's your criteria for success. You're going to first find out what is the domain of your function, which we've done previously. You'll determine the shape of your graph using the base of the log, the sign of the a value, positive or negative, and the domain. And then at the end, we're going to write a one-sided limit statement that indicates the function behavior as the input values approach the vertical asymptote. So they'll approach from either just the right or the left. Okay, so the first one, we're going to look, we have 4 choices, A, B, C, and D, and we want to know what shape is this graph going to have. So I would first look at what is the domain. Now the argument is just x, there's not much going on here. So this is our vertical asymptote, and we can test x equals 1 and test x equals -1. Of course, we need to make sure the argument is greater than 0, so the right half here is going to be the one that works. So our domain is going to be from 0 to infinity. So that's the first thing we know, is that it's going to have to be either D or A, because both of those show the graph to the right side of the vertical asymptote. Now these are not exact graphs, this is just the shape of it. So that could be the y-axis, it could be another vertical line, but we're just going to kind of go with the best fitting graph out of the 4 choices. So when we have the A value, which is positive, there's no issue with any sort of reflection, so that we don't have to worry about. The base, however, so if the base is less than 1, I'll have a capital B, and greater than 0, then the shape is going to be like this. Okay, and we looked at this, we said this was the same as reflecting across the x-axis. So we did that last class. So for this one, our answer for this one has to be D. That's the best fit. So now we want to do our one-sided limit. We want to find out, as we get closer and closer to plugging in inputs near the vertical asymptote, what is the graph doing? And we can see here the graph is going up to infinity. But we need to write down what is x approaching and from which direction. So we're getting closer and closer, plugging in values closer to the asymptote. Now we said the asymptote is right at 0. And we're coming in, you can tell we're coming in from the right. So as x approaches 0 from the right, that's the little plus sign there. It's a one-sided limit. The outputs are approaching infinity. So we're going to do 3 more of these. Same type of situation. We'll analyze where is the asymptote. We'll see if there are any reflections, any issues with the base that we want to look at, and then we'll pick the best shape for the graph. Okay, so example 2 is similar. However, we have this negative to deal with, which means we are going to reflect across the x-axis when the A value is less than 0. So if our A value is less than 0, we need to reflect. Now, we already know what this base did to our graph. It looked like this. So now we need to think about, if we reflect that across the x-axis, it's going to have to look like this. Now let's verify. I'm kind of jumping ahead here, but I wanted to get an idea of kind of like, where are we at? Let's take a look at the vertical asymptote to make sure we're in the right spot. So again, we go ahead, we're here at 5. We can test x equals 6 and x equals 4. If I plug in 6 in for x, we get a positive value. That works fine. However, if I plug in 4 for the x, I get a negative value. That does not work. So the domain is from 5 to infinity. That tells us the two arrows I put, these are both to the right of the vertical asymptote. That makes sense. Okay, so now we know the base is between 1 and 0. So that shape is like this. And then reflect. So my shape has to look like this. So it has to be A for this one. Now, let's think about the limit statement. As I get, let's say this here, this is my vertical asymptote. Let's say this is x equals 5, okay? As I get closer and closer to 5, from which side? Oh, from the right side. Where's my graph going? To negative infinity. So as I get closer and closer to 5 from the right, I'm traveling in from the right, my function outputs are approaching negative infinity. Okay, just 2 more of these. All right, so for this one, we can see our base is 3, and we have this negative a value, which is a reflection. Let's set the argument equal to 0. Here's another boring one, right? We have 0, test x equals 1, and test x equals negative 1. Of course, the positive side works, the negative does not. So the domain is from 0 to infinity. And this is my vertical asymptote. Now, when the base is greater than 1, my graph, when the base is greater than 1, the graph is going to look like this. Then reflect. Okay, so again, we're going to the right of the vertical asymptote. So that's going to be either here or here. This is what it first looks like in A. And then when we reflect it, it looks like D. So now let's come in again from the right. As I come in from the right, as x approaches 0 from the right, my outputs are approaching infinity. Now the difference with this one is looking at this plus 2. All this does is brings your graph vertically up 2. It does not affect the domain. It does not affect that end behavior. So that is all going to remain the same. So that's with this example, that's actually not going to have any bearing on your limit statement or on the domain of your graph. Now, example 4, here's where things are going to get a little different. Here's my base. The base is still greater than 1. So we think about, okay, what does that graph look like? So that graph looks something like this, okay? And then, oh man, we're going to have to reflect across the x-axis, right? So then after I reflect, so A is less than 0, which means we're going to look like this. And now here's the new part with this example. Take a look at this. 2 minus x equals 0. 2 equals x. Let's test. So test x equals 3 and test x equals 0. So when I plug in x equals 0 in for x, I get a positive argument. This side works. On the right side, if I put a 3 in, nope. So the domain is going to be from negative infinity to 2. Now this tells me it's going to have to be B or C. See how those are both to the left? So now we need to focus on, okay, it's to the left. How is this going to look? And it's going to have to be C. Okay, so we have C. So now we want to think about, okay, I'm coming in from the left. So this is different. I'm coming in from the left, approaching the asymptote, which is 2 from the left side. Where is my graph going? My outputs are going to infinity. Now, if you ever get stuck, you could certainly plug in values. And I think the more you practice this, you'll get a feel for what is happening, where are the reflections, which side of the asymptote am I looking at. But until you get comfortable, feel free, plug some points in. You guys can also go to Desmos and type some stuff in to explore those functions further. Okay, and we'll practice more in class.